Hey everyone, I am going to do a quick video to go over a Chapter 5 review, and this mainly just covers the beginning of Chapter 5, or I guess kind of the middle part. This is the stuff that would be on your Week 7 weekly review, so if you haven't started that yet, this should give you a good idea of what to expect, and hopefully kind of help you to be successful on that weekly review. So what I gave you was this Chapter 5 review, and mainly going over thinking about multiplication rule, reading contingency tables, all that. So this first one here says, to test his free throw skills, a basketball player shoots 200 free throw shots in a row, and he makes 171 of them. Based on this, what is the probability he will make his first free throw in his next game? And this one wants you to write your answer in decimal form. So what I have here is just your possible answers. So think about which one you think is correct. So the correct answer for this one would be B. B is 0.855. And we find that by doing 171 divided by 200. So we're using empirical probability here, right? Because we're actually using his data of how many free throw shots he got before to estimate what his probability is of getting his free throw in the next game. So the next one, we have a contingency table. Contingency tables are a way to show different variables and then calculate different probabilities of either, the probability of A, or maybe the probability of A and B, or A or B. So lots of different things we can find from this. So this one asked you, what is the probability a randomly chosen person would be married or have a bachelor's degree? So married or have a bachelor's degree means, we're looking here at the bachelor's column and then the married row. Now, overall, if we're just looking at a randomly chosen person, we're going to use this 300 total as our denominator, right? So married or having a bachelor's degree, the probability that someone is married is going to be 150 over 300, okay? The probability that someone has a bachelor's degree would be 84 over 300, okay? And so if those two things were mutually exclusive, then we could just add those two probabilities together, and that would be our answer. But they're not mutually exclusive because we see up here that it is possible to be married and have a bachelor's degree, right? So there's 45 people in here that would fall into both categories. And so when we add these probabilities together, we end up double counting that 45, right? So the general addition rule tells us that we need to add these two together, but then subtract that 45 over 300 probability. So we would get 150 over 300 plus 84 over 300, and then minus the 45 over 300. And when you take that from a fraction to a decimal, you would get the 0.63 here. So that would be our answer. The 0.15 here, that would be if we wanted to know the probability that someone would be married and have a bachelor's degree, because that would be that 45 over 300 number. So if you thought it was B, you probably just were thinking about married and having a bachelor's degree, but we want to look at the OR probability. All right, the next one, we're spinning a prize wheel. It's got 10 equal areas. We're assuming that the prize wheel is fair. It's equally likely to fall on any of the spots. And then we have a jar of marbles that has 4 colors that are all equal numbers in there. So we don't know exactly how many are in there, but we do know that they're all an equal number of those 4 colors. So what's the probability that I spin a 7 and choose a red marble? Okay, so with and, we're going to use the multiplication rule if we can. Okay, and the multiplication rule says that if our events are independent, we can just multiply those probabilities together, right? And so the probability of spinning a 7 is 1 out of 10, right? So we have 10 spots on this wheel, and 7 is just one of those spots. So it would be 1 out of 10 chance of spinning a 7. And then for choosing a red marble, since there are 4 colors and they're all equal, the probability of choosing a red marble would be 1 out of 4, right? Because there's 4 different colors and they're all equal amounts in that jar. Now, these would be independent events, right? Because if I spin a 7, that wouldn't make me more or less likely to choose a red or a green or a blue marble, right? They don't have anything to do with each other. So we would multiply these together, and we would get 1 over 40, which this one actually wanted you to have your answer as a fraction. So we would get the 1 out of 40 as our answer for this one. All right, so this last problem is kind of similar to one of the other examples we did in class where we were looking at a new COVID test and the probability that people would get a correct result or an incorrect. So kind of the same thing here. We're looking at a certain nursing program. There's a 31% chance that a student will fail their first year of classes. If you randomly choose a group of 5 students starting that program, what's the probability that none of the nurses pass their first year of classes? So the probability that none of them pass, that means that they all failed, right? And the probability of one person failing is 0.31. So we would use our multiplication rule here, and assuming that all of these would be independent, so all of these students failing are independent of each other, that if person A fails, that shouldn't make person B more likely to fail or any of that. For assuming all that's true, then we're just going to multiply 0.31 together 5 times, or we raise it to the 5th power. So 0.31 to the 5th is 0.0029. Okay, so we do that because we assume that each of these people starting the nursing program have a 31% chance of failing their first year of classes. So we just multiply all those probabilities together. We're raising it to the 5th power because there were a group of 5 students. So that's why we're using 5. All right, what's the probability that all of the nurses pass their first year of classes? So all of the nurses passing, right, would be, if you pass, that's the opposite of failing, right? So if the probability of failing is 0.31, then we will use the complement rule, right, to find the probability that they will pass. So 1 minus 0.31 is 0.69, so that is the chance that they will pass, right? And since we have 5 of them again, we would take 0.69 and raise it to the 5th power, and that will give us D, right? 0.1564. So the probability that all of them will pass their first year of classes is about 16%. Okay, and then the last one, what's the probability at least one of the nurses passes their first year of classes? So we looked at an example similar to this in the notes, but this at least one, typically what we're going to do with that is we're going to look at the opposite, right? So what is the opposite of at least one? Okay, so that's supposed to say opposite, O-P-P there. The opposite of at least one is none, right? 0. If we're looking for the probability of at least 1, we would rather find the probability of 0 or of none and then subtract from 1, right? So what we want to do here is 1 minus the probability that none of them pass their first year classes. All right, and that probability we actually already know, right? We did that in part A. So this is the probability that none of them pass their first year, the 0.0029. So for this, we would do 1 minus 0.0029, and then we get the 0.9971 for our answer there. Okay, so this is just a quick overview of some of the topics that we talked about in, I guess, 5.2 and 5.3. Then at the end of Chapter 5, we are looking at counting techniques using combinations and the multiplication rule of counting. Feel free to let me know. You can contact me for help with that. You can contact our math tutors on campus that have free tutoring, but just whatever you want to use to help you succeed in your class or succeed in this class. Want to make sure that you know that there's lots of available resources for you. All right. So hopefully I will see you in class later this week.